We're going to look at absolute value of a function. You've looked at what absolute value means before. I mean, we even talked about it last time, I think, and maybe that was in my other class. Kind of losing my mind a bit, but the absolute value of a number is essentially just the distance without worrying about the sign plus or minus, right? We've talked about this, yes? No? The absolute value of 5 is 5. The two lines mean absolute value. Absolute value of 5 is 5 because it's 5 units away from 0, right? This is how far it is. You don't care about which direction it is. It's 5 units. It doesn't matter the positive, negative. Negative 5. Absolute value of negative 5 is 5. When you talk about the absolute value of a number, you're saying, I don't care whether it's this direction, that direction. You're just interested in this. Speed is absolute value of velocity. That's a kind of what you might be able to get your head around here. The speed is the absolute value of velocity. You know the difference between the two words, speed and velocity? Yes, no? Velocity has a direction to it. Like if you're taking physics, you might set up a set of axes or coordinate system or something where, this direction is positive, this direction is negative. And you talk about, if something is, here's the object. If something is moving one way or the other, like you might say, I might decide that this direction is a positive direction and call that its speed the positive. But then if it starts moving this way, that speed is called negative because it's the other direction. Did I just use the word speed too? Velocity. Velocity is the one that the sign. You can say I'm going plus 50 meters per second or minus 50 meters per second. The speed in both those cases is absolute value of that. It's 50. You have a speed limit, not a velocity limit, right? If it was a velocity limit of 100 kilometers per hour, then if you're going backwards 200 kilometers per hour, you'd be okay, right? It's not a velocity limit, it's a speed limit. You don't care about the sign and direction, as the number itself is what matters. Okay? This stuff is just review, again, assuming you know what absolute value is. Not trying to insult your intelligence here, but just make sure you understand whether a number is positive or negative, its absolute value is just the number. I mean, it's positive, right? But 2/3, 3.6. Absolute value of 0 is 0. Which numbers change? This is the key to this absolute value graph. I said it in this very mathematical, technical way here. Which numbers changed? The negative ones, right? That one changed. It became positive. That one changed. 0 or positive numbers stay the same. Negative numbers become positive. If you want at some point to put a definition in there of absolute value, that's fine with me. I don't want to actually, sorry, I was thinking it was just explain that. Formal definition, we're going to put that in here after we've looked at the graph. It makes more sense after we've looked at the graph. Absolute value of a negative number is a positive number. Any negative values in the graph will become positive. If I take a function f of x and I've got some values that are positive and some that are negative, let's just define this function with some numbers. Give me some random pairs of numbers, single-digit numbers, just whatever you want. 3, -7. Somebody give me another one. Doesn't matter. 2, 9. Okay, what else? 1. It's a completely random function, but 0, that's a good one. 0. 4. Let's go for some negatives here. -4, -7, and that's probably good enough, isn't it? -5, 3. If this is f of x, if I want to know now what set of points would be on absolute value of f of x, if I do the absolute value of that function. So the first thing here is y equals f of x. And then I want to do y equals absolute value of f of x. I need to create a bit of space here first, I think, so we can see them both at once. So this is this one, which we will move over here. And then we're going to make another table for y equals absolute value of f of x. This one's going to be absolute value of that function. You don't just take every single negative number in there and make it positive. You think about what's happening. This change is happening. You know how when we've had y equals f of x, if we've made a change before we apply the function, like inside here, inside the brackets, what does it change? What coordinates does it change? How does it change the points? Horizontally, vertically? If you make a change inside here, how does it affect the function? Yeah, like if I put, well, I mean, you're probably getting pretty good at it now. You put a 2 in there, that affects it horizontally. You put a 2 out here, it affects it vertically. If we do an absolute value outside here, what coordinates is it going to affect? If it's after the function has been applied. After the function's been applied means like a function is just, when you first learn what a function is, here's f, it means you put in a number and you get out a number. You put in a 3, you get out a negative 7. You put in a 3, you get out a negative 7. Right? That's all it does. It turns a 3 into a negative 7. But now if I'm doing absolute value of that function, like after I put the number in, I'm doing that after I apply the function. So I'm actually going to show it as another little machine down here. It's another thing that does, and we're going to call it absolute value. What comes out now? What does this absolute value machine here do? It's another function, right? It's a function on your calculator. You have a 3, you put it in, f turns it into a negative 7. Negative 7, you put it absolute value, turns into positive 7. That's all this does. We just talked about that, right? Absolute value of a number makes it positive. Instead of this point, okay, instead of this point that was 3, negative 7, what's the new point that's on y equals absolute value of, I'm going to make another table over here that represents y equals absolute value of f of x. What point is on there? 3, negative 7 was on f of x. What's on absolute value of f of x? What point did we come up with? We put in a 3 and eventually we came out, we got a 7, right? 3, negative 7 became 3, 7, right? Because the absolute value is applied after you do the original function. What about these other points? If I put in a 2, and what do I get out of f here? I put in a 2, what do I get? Put in 2, you get a 9, put that in the absolute value thing, does it change it? Keeps it the same. 2, 9 stays the same. 1, 0, is that going to stay the same or change? Stay the same. 0, 4, is that going to change or stay the same? It stays the same. What about this one? Does this become the point 4, 7? Negative 4, 7? 4, negative 7? Or does it stay like that? What happens? You can put it in here and find out. Here's a negative 4. Right? You're still putting that in. What does this f turn it into? It turns it into a negative 7. And then eventually turns it into a 7. What point is on y equals f of x? What point corresponds to this on, an absolute value of f of x? What point corresponds to that? Negative 4 and 7. I bet a lot of you wanted to say, well, you're not allowed to have this negative here if it's absolute value. This x value doesn't change. The y value changes, right? You're still putting in a negative 4. It doesn't change that. It changes the y value. It's happening after you've applied the function. All it does is it says whatever comes out, we're considering them all to be positive. So what does that mean on a graph? Well, in this point, does this point change? No, it doesn't. It's negative 5, 3. That's already positive. It came out of here positive, so it stays positive. On a graph, what does it mean? I better stop this and start it again before we find